Hello and welcome. In this video, let us test to see if two lines are parallel, perpendicular, or neither. Sometimes we are given two equations and are asked to prove if the two equations are parallel or perpendicular, or if they are neither parallel nor perpendicular. When we do this, there are two main cases to look for, the parallel and perpendicular. For the parallel lines, if the two slopes are the same, and the two y-intercepts are different, then the two lines are parallel. The symbol for parallel is the two lines that are vertical, that run side by side and sort of look like two parallel lines. The second possibility is if the slopes are negative reciprocals of each other. The signs are opposite and the numbers are flips of each other. Then these two lines would be perpendicular. The symbol for perpendicular is the upside down capital T, which sort of looks like two perpendicular lines. Another way to test for perpendicularity is to multiply the two slopes. If the two slopes multiply to -1, then the two lines are perpendicular. If neither one of these two situations happens, then the lines are neither parallel nor perpendicular. So let's look at 4 examples really quick and see if the examples represent parallel or perpendicular lines or neither. The first example, we have two lines and the slope of the first line is 3. The slope of the second line is -1/3. So if we were to multiply 3, the slope of the first, this is m1, this is the slope for the second, this is m2. And if we were to multiply 3 times -1/3, we would get -3/3, which is -1. This is a proof that the two lines are indeed perpendicular. So our conclusion is the two lines are perpendicular, and we can simply write a symbol for perpendicular. The second example, here are two lines, and the second equation is already solved for the y, so we can read the slope. The slope is -2/3. The first example is not solved for the y, and we don't know what the slope is, so we can't really compare it to the second equation. So first thing to do is to solve for the y. So let's do that. To solve for the y, we need to cancel plus 2x, and to do it we minus 2x from both sides. That makes 3y equals to -2x plus 10. To cancel the multiplication by 3, we divide each term by 3. So now we have our equation solved for the y, which means now we know what the slope is for the second line. The slope for the for the first line is -2/3. The slope for the second line is exactly the same, -2/3. We know that the y-intercepts are different, 10/3 and 8. These are two different lines with exactly the same slope, which means these two lines are parallel. We can write two lines side by side. This means the two equations represent parallel lines. Example number 3. Both examples are solved for the y. We read the slope for the first line, it's 3. The slope for the second line is 1/3. The numbers are reciprocals of each other, but they are not negative reciprocals. So if we multiply the two slopes together, we're going to get +1, not -1 that we need to prove that they are perpendicular. So these lines are neither parallel, because slopes are different, nor are they perpendicular. The answer is neither. And the last example, we have two special cases, and it may be easiest to picture them on the number line. The first special case represents the vertical line running through 3, x equals 3. So this is our line number 1. The second is a horizontal line that runs through y equals 3. So of course the horizontal and vertical line are perpendicular to each other. Even though we cannot multiply the slopes to get -1, we know that the two lines are indeed perpendicular. So the conclusion is perpendicular, that's a symbol for perpendicular, And that's it. If you have any questions on anything, please let me know. This is how to test if the two lines are parallel, perpendicular, or neither. If you have any questions or would like to see some of your own questions discussed, let me know. Look forward to hearing from you. Thanks for your time.